Assalamualaikum to the respected lecturer. My name is Diyanah Binti Muhammad Nizam, a final year student from the Bachelor of Science Chemistry with Management, University Technology Mara. Today, I would like to present my industrial training experience at my CO2 PG Sdn Bhd, which was conducted from 30 March 2026 until 3 July 2026. Throughout this presentation, I will briefly introduce the company, explain the tasks and projects that I carried out during my internship, discuss the knowledge and skill that I gained, and conclude with several recommendations. First, I will introduce the background of my CO2 Sdn Bhd. My CO2 PG Sdn Bhd is an independent laboratory established in 2006 that provides testing, inspection, certification, and environmental monitoring services. The company operates laboratories in Penang, Kuala Lumpur, and Johor Bahru, serving various industries such as manufacturing, environmental consultancy, pharmaceutical, food and beverage, medical device, and petrochemical industries. The laboratory is accredited under ISO IEC 17025, which ensures that laboratory testing is performed using validated analytical methods under an effective quality management system. The company vision is moving toward digitalization and globalization, while its mission is contribute to business excellence. During my internship, I was first attached to the Environmental Health and Safety or EHS department. This department is responsible for environmental monitoring and regulatory compliance services. Its main activities include ambient air monitoring, ambient noise monitoring, wastewater studies, environmental assessment, and environmental impact assessment or EIA to ensure industry comply with the environmental regulations. After completing my attachment in the EHS department, I was assigned to the metal department. The metal department performed heavy metal analysis for different sample metrics such as wastewater, drinking water, biological, and industry samples. My responsibility mainly focused on sample preparation before ICP-OES analysis following the laboratory standard operating procedures. This slide shows the organizational structure of my CO2. The company is led by the board of directors followed by the chief executive officer. Several divisions operate under the CEO, including laboratory and technical services, quality assurance and accreditation, business development, and administration. As an intern, I was placed under the laboratory and technical services division. My CO2 provides various laboratory services to support quality assurance and regulatory compliance. Its core services include environmental monitoring, wastewater testing, drinking water analysis, heavy metal analysis, food safety testing, pharmaceutical testing, medical device testing, and inspection and certification services. These services help industry comply with the national and international standards. Next, I will explain the tasks and projects that I carried out during my industrial training. My industrial training involved two departments, namely the Environmental Health and Safety Department and the Metal Department. Throughout the internship, I was exposed to environmental monitoring, laboratory documentation, sample preparation, and analytical testing. All assigned tasks were performed according to ISO IEC 17025 laboratory requirements, ensuring accuracy, traceability, and quality in laboratory operations. The main objective of my industrial training were firstly to gain practical exposure to industrial laboratory operation, secondly to understanding environmental monitoring and analytical testing procedures, thirdly to apply the theoretical knowledge learned at university in an industrial environment. In addition, I aim to improve my communication, teamwork, and problem-solving skills while understanding laboratory quality management and regulatory compliance. In the EHS department, I was mainly involved in report preparation and environmental data processing. The workflow started by receiving environmental monitoring data and field worksheets. Next, the monitoring data was extracted and processed using Microsoft Excel. After analyzing the data, I generate ambient noise boundary graph, before preparing technical reports, including ambient air, ambient noise, air emission, and industrial influence characterization study reports. Finally, all the reports were reviewed, compiled, and properly documented before submission. For the method department, the first method is wastewater analysis. For wastewater analysis, the sample was first homogenized to ensure it was well mixed. A measured volume of the sample was then transferred into a beaker before nitric acid was added for acid digestion. The sample was heated on a hot plate to dissolve for the heavy metal into solution. After cooling, the solution was filtered, diluted to the required volume, and transferred for ICP-OES analysis. This preparation step is important because acid digestion helps dissolve metal ions, reduce matrix interference, and improve the accuracy for heavy metal determination. For drinking water samples, the preparation procedure was relatively simple because the sample generally contained fewer suspended solid. The sample was first homogenized and filtered before being transferred directly into a centrifuge tube for ICP-OES analysis. This procedure helps remove suspended particles while ensuring that the sample is suitable for instrumental analysis. Urine sample require a more extensive preparation because they contain organic compounds that may interfere with instrument analysis. Nitric acid and hydrogen peroxide were added before digestion to oxidize and remove the organic matrix. After digestion, the solution was cooled, filtered, dilute to the required volume, and transfer for ICP-OES analysis. This preparation improves analyte recovery and ensure reliable heavy metal determination. For residue on ignition analysis, the empty crucible was first heated in a furnace and weighed. Approximately 5 grams of sample were then added before heating at 6 degrees Celsius. After cooling in a desiccator, the final weight was recorded to determine the amount of inorganic residue remaining after ignition. This analysis is commonly used to determine the inorganic residue present in the sample. For sulfated ash analysis, the empty crucible was first conditioned and weighed before approximately 1 gram of sample was added. Sulfuric acid was then added before the sample was heated on a hot plate and transferred into the furnace. After cooling, the final weight was recorded to determine the sulfated ash content. The addition of sulfuric acid converts inorganic compounds into stable sulfate, allowing more reliable determination of inorganic residue. Throughout the industrial training, I gained valuable knowledge in the environmental monitoring, laboratory analysis, and ISO IEC 17025 quality management practices. I also developed practical laboratory skills including sample preparation, analytical techniques, environmental report preparation, data analysis using Microsoft Excel, and laboratory documentation. Besides technical skills, the training improved my communication, teamwork, time management, and ability to work independently in professional laboratory environment. In conclusion, the industrial training at MyCO2 provide valuable industrial exposure in both the environmental health and safety department and the metal department. The experience strengthened my laboratory knowledge, technical competency, and professional confidence while preparing me for future employment in analytical, environmental, and quality control laboratories. Now we go through with the impact of industrial training. Throughout my industrial training, I gained knowledge in environmental monitoring, analytical testing procedures, ISO IEC 17025 laboratory requirements, and environmental regulations. I also learned how these concepts are applied in daily laboratory operation, particularly in sample preparation, documentation, and quality management to ensure reliable analytical results. During the training, I developed several technical skills including sample preparation, data analysis using Microsoft Excel, environmental report preparation, and testing documentation. This practical experience improved my laboratory competency and gave me better exposure to real industrial laboratory practices. Besides technical skills, this industrial training also improved my personal development. I become more confident in communicating with colleagues, work effectively as part of a team, improve my time management, and strengthen my problem-solving skills while handling daily laboratory tasks. Now, we are already in the last part of this presentation, which is conclusion and recommendations. In conclusion, I successfully complete my industrial training at my CO2 Syndrome Berhad, where I gained valuable practical experience in laboratory operations. The training strengthened my knowledge, improved my laboratory skill, increased my professional confidence, and better prepare me for a future career in the analytical and environmental industry. For future improvement, I recommend continuing to provide more hands-on laboratory activities for interns. In addition, interns should be given greater exposure to different analytical instruments and testing methods. Lastly, preparing separate sample portions for each testing department could help reduce waiting time, minimize contamination risk, and improve laboratory workflow efficiency.